我都知啦，你有冇搞錯咗啊？
我講得出嚟，我就梗係唔會搞錯啦。呢啲蠔油係講緊用蠔入邊嘅嘢去整一啲油去油你屋企埲牆嘅。
吓？咁屋企咪變咗豪宅？
咁我係幾豪㗎？咁想知有幾豪咧，就交俾我哋聖保羅男女中學嘅同學啦。
好，唔該晒咁多位同學。
Hey, what is that smell?
Oh, nothing special, I'm just painting the wall.
I bet it's the VOC that is responsible for such irritating smell. Is there any paint that is environmentally friendly and doesn't smell bad at all?
Well, of course there is, like, well, Microsoft Paint, right?
Maybe oyster paint will do. Oyster paint is our invention. It's easy to make, environmentally friendly, and of high quality. The main ingredient is waste only.
This board displays the comparison between the commercial latex paint and our invention.
During the invention process, we learned that commercial latex paint contains a binder, which binds the ingredients together. So we discussed whether there are natural substitutes as a binder. One day, I came across some cream on the cake, which is white, smooth, and sticky. Milk, the ingredient of the cream, may be the substitute we are looking for.
After doing researches, we discovered the presence of the milk protein, casein. Casein reacts with calcium hydroxide to produce binder, calcium caseinate, which is used as a glue in ancient Egypt. We then used a carton of milk to experiment. However, the paint was hard to dry, having low viscosity and opacity. The surface even cracked and became powdery after drying.
So surely there's something missing in our paint. We tried adding various natural substances into the paint. For example, leaves and eggshell, but the effect was still unsatisfactory. One day, I was having dinner in a seafood restaurant, and one of the food was oyster. Then I thought, oysters are so expensive, but only the meat is consumed. Isn't it a bit of waste? So we grinded the oyster shell into oyster powder and added them into our paint. The result was totally unpredictable. Not only our paint has a higher opacity and adhesiveness, it also has a very smooth surface.
So, what exactly is oyster shell made up of? We carried out many tests, and finally, we used hydrochloric acid and lime water to test that oyster shell contains carbonate ions. After gathering information, we confirmed that oyster shell consists of over 97% of calcium carbonate. Calcium carbonate and calcium caseinate are attracted to each other as the Richter equation.
To find out the best ratio of ingredients, we use 4 criteria to assess different composition. They are drying time, adhesiveness, hardness, and water repellent ability. The objective of drying time test is to look for the formula with optimum viscosity, so that our invention won't be too sparse to adhere or too saturated to spread out. It is conducted with accordance to adhesiveness test. The hardness test and the water drop test are to find our formula with the best crack-proof and water repellent ability respectively. We have tried many different compositions. Some of the results will be presented in the following section.
Drying time is related to the viscosity and the ability to level off brush marks. Formula with only 13 milliliters of milk produce a paint with many brush marks, while formula with 16 milliliters of milk produce a smooth paint.
As for the adhesiveness of the invention, we stick different tapes on it and glue them out. Formulas with 15 or 16 ml of milk, 10 grams of calcium hydroxide and oyster shell powder have similar performance with latex paint, while paints with only calcium hydroxide and milk have a low adhesiveness, and this table shows some of the results.
In the following video, a 69.4 gram of copper ball is dropped onto the paint from a distance of 1.5 meters to test for the hardness of our invention. This is a sample of 15 gram calcium hydroxide plus 15 ml of milk. A lot of powder is flicked off from the paint. while the other paint with oyster shell powder showed no sign of damage. The highlighted part of the formula performs as good as latex paint.
As for water drop tests, time for a water droplet to slide down 8 cm vertical paint surface is recorded. Our invention outperforms latex paints in this criterion.
After analyzing all results from the test, latex paint was used as a reference with the rating of 3 in a scale of 1 to 5. The formula with 60 ml of milk, 10 grams of oyster powder and 10 grams of calcium hydroxide got the highest rating in most tests. It is even more water repellent than the commercial paints.
However, we were still not satisfied with the waterproof and stain-proof ability of our invention. The fact that oil and water cannot mix together came into our mind, so we experimented adding different plant oil to our invention. Latex paint tend not to repel water, and water drops slowly. On the contrary, our invention repelled water, and droplets are formed on it.
In this video, soy sauce is dropped onto the latex paint. After cleaning, there is still an apparent stain. There is also stain on paint without oil. On the contrary, soy sauce on our oil at the invention was removed easily after 10 minutes. Plant oil does enhance the waterproof and stain-proof ability of our invention, which outperforms commercial latex paint in those two areas.
But is it too dull to have only white paint?
Well, to solve this problem, we extracted a red pigment named anthocyanin from dry scale leaves of onion. Other pigments can also be used as the samples showed to you.
To increase the pot life and the mold resistance of our invention, we tried to precipitate casein out of milk by adding acid. Casein can even be extracted from spoiled milk simply by filtration. This favors commercial mass production.
Well, we further carried out 2 tests to investigate the mold-proof ability of our invention. Samples were put in bathroom and around pieces of bread with mold respectively. Mold is even rubbed on the sample surface in the latter test. Still, no mold can be found on our invention.
Calcium hydroxide is the only cause of our invention. Furthermore, 1.8 kilograms of waste is reused per liter of our paint. Spoiled milk and oyster shell may be collected from retailers, milk farms and oyster farms respectively.
For further investigation and industrial production, even more natural ingredients can be used, since we find that some of the mollusca, including clam and scallop shells, are possible substitutes for oyster shell.
Our invention uses waste like expired milk, oyster shell, and onion skin. It's easy to make, environmentally friendly, and of high quality. Next time when you renovate your house, consider using our oyster paint. Save a penny and save the earth. Thank you.
好，唔該晒咁多樂評配音，4分鐘嘅發問時間有請咁多位評判嘅。